Hey guys, it's me again with 14.6. So now we're doing triple integrals, and our first triple integral will be the one of the region E of e to the y cosine z sine x dv, where x is bounded by 0 and pi over 2, y is bounded by 0 and 1, and z is bounded by 0 and pi over 2. And I'm going to do this in order of dy, dz, dx. So our limits of integration are going to go 0 pi over 2, 0 pi over 2, 0 to 1. And I started integrating right after that. So we see that e to the y is going to give us e to the 1 minus e to the 0 times cosine z sine x dz dx. 0 to pi over 2, 0 to pi over 2, which gives us e to the 1 times the double integral, both 0 to pi over 2, of cosine z sine x dz dx. So we have e to the 1 times the single integral from 0 to pi over 2 of sine z evaluated from 0 to pi over 2 sine x dx, which gives us e to the 1 times 1 times the integral from 0 to pi over 2 sine x dx, which just simplified as e to the 1, or e minus 1, times the integral from 0 to pi over 2 of sine x dx, which gives us e minus 1 times the negative cosine of x from 0 to pi over 2, which gives us e minus 1 times a positive 1, which just gives us e minus 1 times positive 1, which is e minus 1. Because right here we have a negative 1, which is positive 1. And that's your answer for that one. It's just evaluate this integral given all these things. But this one over here has a bit more work to it. So we're finding the volume of a solid enclosed by y squared equals c, x equals 0, and x equals y minus c, which also equals y minus y squared, which you'll see why that's useful later. So we see z is bounded by y squared, and if we solve for z, z equals y minus x. So it's bounded by those two functions, which since z has both y and x in it, we're going to be integrating in terms of z first. And then we see that x is going to be bounded by 0 and y minus y squared, because x equals y minus z, which also equals y minus y squared, because z equals y squared. Which means we're going to be integrating in terms of x second because it has a function of y. And now solving for our y limits, we see that x equals y minus y squared. So we set x equal to 0 and solve for y squared, which is y. So y squared equals y is only true when y equals 0 and y equals 1. Therefore, the limits for y are 0 is less than or equal to y is less than or equal to 1. So now we can just plug all this into our integral. So we have 0 to 1, 0 to y minus y squared to y minus x, dz, dx, dy. Integrating in terms of x, you have the double integral 0 to 1, 0 to y minus y squared of y minus x minus y squared dx, dy. And taking the integral in terms of x, you have the single integral of 0 to 1 times y, or of y times x minus x squared over 2 minus x times y squared, evaluated from 0 to y minus y squared dy. Which, getting rid of the x's and putting in our y's, we have the single integral from 0 to 1 of y squared minus y cubed minus this fraction, y squared minus 2y cubed plus y to the 4th, that's not a 4 to the 4th, that's a y, over 2, minus y cubed plus y to the 5th dy. And now just kind of simplifying something, you see that there's a minus y cubed here and a minus y cubed here. So we're going to say that the single integral from 0 to 1 is y squared minus 2y cubed minus the fraction y squared minus 2y cubed plus y to the 4th over 2 plus y to the 5th dy. And now I'm distributing out the integral to make this a bit easier to do. So the integral of y squared is y cubed over 3 from 0 to 1, minus the integral of 2y cubed is y to the 4th over 2, 0 to 1, minus 1/2 times the integral of y squared minus 2y cubed plus y to the 4th dy. We'll get back to that later. Plus y to the 6th over 6 evaluated from 0 to 1, because that's the integral of y to the 5th. So we have 1/3 minus 1/2 minus 1/2 times y cubed over 3 minus y 4th over 2 minus y to the 5th evaluated from 0 to 1 plus 1/6, and then our 1/3 and our 1/2 and our 1/6 is going to become 0 eventually, because you see that this is going to become 2 over 6 plus our 1 over 6 is going to be 3 over 6 minus 1/2, which is 3 over 6 equals 0. So we see that we have negative 1/2 times 1/3 minus 1/2 plus 1/5, which turns into negative 1/2 times 10 over 30 minus 15 over 30 plus 6 over 30, which equals negative 1/2 times 1 over 30, which equals negative 1 over 60. And that is the end of the examples that I have for 14.6.